We are solving a NEET 2019 question from rotational dynamics. A solid cylinder of mass 2 kg and radius 4 cm rotating about its axis at the rate of 3 rpm. What's the torque required after a revolution of 2 pi? So if I have to find out the torque, what I need to know? Torque, we know the formula as I alpha, where I is the moment of inertia, alpha is the angular acceleration. Moment of inertia of a solid cylinder about its natural axis is mr square by 2. Mass is 2, radius is 4 centimeter, that is 4 into 10 power minus 2 whole square by 2, that is 16 into 10 power minus 4 kilogram meter square. So I got I need to know alpha so that I can get the problem. For that, what he has given is it is revolving with RPM. Torque required to stop, that means omega initial is 2 pi into n. N is number of revolutions per minute. 3 revolutions per minute is given, where n is number of revolutions per second. So by 60 has to be written. Then it becomes radian per second, right? So this becomes pi by 10 radian per second. It's finally coming to the state of rest, so omega finally equal to 0. So similar to our v square minus e square equal to 2as in translatory motion. In rotatory motion, we have omega final square minus omega initial square equal to 2 into alpha into theta. Instead of linear velocity, angular velocity. Instead of linear displacement, angular displacement. Instead of linear acceleration, angular acceleration. Now, what is that theta is? After 2 pi revolutions. So for each revolution, it covers an angle of 2 pi. So the total displacement after 2 pi revolutions is 2 pi for one revolution. After 2 pi revolutions means 2 pi into 2 pi radian. Now I know everything. Omega final is 0. Omega initial is pi by 10 whole square. 2 into alpha into theta is 2 pi into 2 pi. It implies minus pi square by 100 equal to 8 alpha pi square. Pi square can be cancelled. Alpha equal to minus 1 by 800 radian per second square. Minus is a symbolic way of saying that it is acting against the rotatory motion. That's why it is stopping. Now I know alpha, I know I. That implies I can calculate torque using a formula I alpha. It is found as 16 into 10 power minus 4. Alpha value I have found it as 1 by 800. So 16 into 10 power minus 4 by 8 into 10 power plus 2 I can write. That becomes 2 into 10 power minus 6 Newton meter. That's what our answer is. That's how we can solve the problem. It's a simple problem, just a formula based problem. We need to know tau equal to I alpha. We also need to know that moment of inertia of a solid cylinder is mr square by 2. And we also need to know this formula. Of course, we also need to know that omega equal to 2 pi into n. By knowing all these basics, we can easily come to this answer, right? That's how we come to this answer. Thank you for watching.